Hello, calculus friends. Today we are going to talk about modifying Maclaurin series. So now that we've done some creation of Taylor and Maclaurin, the fun fact is that a lot of our base functions have really easy to remember, or maybe I shouldn't say easy, but predictable patterns to them. And then once you memorize and learn those base functions, you can just very slightly modify them to create polynomial approximations for transformations or operations on those. So let me show you what I'm talking about here. So if we look at this Maclaurin page, it says memorize this page. Well, yeah, you need to memorize some of it, but some of it you don't really have to memorize. So at the top here, I have the series for 1 over 1 minus x and 1 over 1 plus x. You don't need to memorize that. What you need to recognize is that 1 over 1 minus x is in a over 1 minus r form. So you can create a series from a fraction, from a rational expression that's in a over 1 minus r form by doing a times r, and so on. And the next one, 1 over 1 plus x, remember if there's a plus on the bottom, that means your r is a negative. So here's a times r times r. So what I'm saying is the first two you don't need to memorize. You just need to recognize that they're in a over 1 minus r form, which means you got a geometric series, and you make it. When we come down here for e to the x, this one is easy to remember. Here's what I tell people. E is everything. E to the x, the power series for e to the x is everything. 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the n over n factorial. And it's true for all x values. Its interval of convergence is everything. Okay, so E for everything because you have every term, even powers, odd powers, and everything is positive. Now, what about sine x? Sine x and cosine x are very similar. Sine x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And if you're noticing, sine x has odd degrees and factorials, and it alternates between positive, negative, positive, negative. All right, so sine is all the odd terms and it alternates. Cosine is all the even terms, x squared, x to the 4th. 1 is x to the 0, and yes, 0 is an even number. So sine is all the odds, cosine is all the evens. And if you're thinking, Mrs. Vibber, I'm never going to remember that, I got two ways for you to remember it. Number one, sine is an odd function because it's a transformation of itself after a rotation of 180 degrees through the origin. Sine is symmetric with respect to the origin. It's an odd function, so it has odd powers. Cosine, which is an even function because it's a reflection of itself over the y-axis, has even powers. Okay? So there's your mathematical reasons for why sine is the odds and cosine is the evens. And here's your really crappy way to remember it. C looks like E, and E stands for even. I know that's dumb, and that's probably the one you're going to remember because it's ridiculous. But if you can't remember anything else, cosine starts with C. C looks like E, E for even powers. But the better way to remember it is to remember that cosine's an even function. All right, now I'm going to jump here for a second and say there's sine and cosine. Now let's come down here and look at inverse tan. Odd, odd, odd. Oh, inverse tan looks just like inverse sine, but it's missing something. It's missing the factorial. So inverse tan and inverse sine are nearly identical, but inverse sine has a factorial and inverse tan does not. And here's the really I'm Elmer Fudd. Here's the really crappy way to remember that. Sine has an I in it. And when you turn an I upside down, it looks like an exclamation point. Tangent does not have an I in it, and therefore does not have an exclamation point. Welcome to Mrs. Vibber's funky house of stupid ways to remember things. And then last but not least, ln 1 plus x. I don't even memorize this one. Honestly, I do ln 1 plus x by just writing it out, by taking the derivatives, and then I figure it out that way. For me, it's just easier. Okay, otherwise I always forget something. So, what should you memorize? Sine, cosine, inverse tan, and e to the x. What should you figure out on your own? The ln's and the fractions. All right. So now, once you've got them memorized, what good does that do you? I'm going to show you. So if we come over here, this page says create a Maclaurin series for each of these, state the first four non-zero terms and the general term for each. Okay, I'm going to number these, and I'd like you to also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. I'm not going to do number 1 and number 2 with you because those are geometric. So just know that number 1 and number 2 are geometric, and you should be able to write those out on your own. And you know what? I've already convinced myself I should probably do one of them with you. I'll do one of them with you. So let's do literally 1. So 1 over 1 plus x cubed, if I wanted to write a Maclaurin series for that and write it out, I would say, well, that's a over 1 minus r, where a equals 1 and r is negative x cubed. So then I start with 1, I multiply by negative x cubed, multiply by negative x cubed, multiply by negative x cubed, making my general term a times r to the n minus 1. Geometric series all have that form of a general term, a times r to the n minus 1. And there's my series. Are there other ways to write that general term? You bet your boots there are, but I'm not going to write them down because we don't need many. Just use that one. So number 2, you can do the same thing. Number 3, negative sine 2x over 3. Well, here's what I'm going to do. If I need to modify a series, I'm going to write out the original and then change what needs to be changed. So sine x, okay, so my series for sine x, well, sine is an odd function, so it has odd powers. So that's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And then my general term is that it alternates. The power on top is odd, and the the factorial on the bottom is odd. Odd, I can use 2n minus 1. And now let me make sure that it's going to alternate with the right starting sign here. Let's see, when x is raised to the 7th, that would be an n of 4. And so if I need an n of 4 to create a 7, negative 1 to the 4th would be positive. I'm off a little, so I'll make that n plus 1. All right, so there's my general term. All right. Now, this is supposed to be negative sine 2x over 3. Well, what I'm going to do first is just deal with the negative. If this is negative sine x, that means I negated the left-hand side. So now I'm going to negate the right-hand side. And negating is multiplying by negative 1. Multiplication distributes across addition and subtraction. So I'm just going to negate every term. So there I went. I negated every term. And so if I come over here and I multiply this by negative 1, now I've got negative 1 to the n. X to the 2n minus 1, 2n minus 1 factorial. Because now I've changed the sign. But I wasn't supposed to just negate it. I was also supposed to replace the x with a 2/3 x. Okay, let's do that. So now I'm going to take that and replace x with 2x over 3 or 2/3 x. So I'm going to do that here. Replace the x's with 2x over 3. Let's see, negative, positive, negative 2x over 3 to the 5th over 5 factorial, 2x over 3 to the 7th over 7 factorial, and even in the general term, I'm going to replace the x with a 2x over 3. And if you're thinking, well, should I distribute that exponent to the 2x over 3? I mean, you can, but you don't need to. You can leave it just like that. That's how easy it is when you know the base function to create any other function you want with sine, kind of every other function you want with sine, is you just modify your polynomial the same way you modified the original. All right. And that's what we're going to do for the rest of these. So I'm going to pick another one here. I think what I want to do is I want to do number 4. Number 4 says they want us to do negative x plus sine x. Well, addition isn't distributive. So if I want to do negative x plus sine x, that means I add 1 negative x to both sides. So I'm going to take this original form for sine x. I added negative x to the left-hand side. So then I am going to add negative x to the right-hand side and then put everything else back. Does adding negative x change my general term? No. No, it does not, because the general term is just what propagates the series later on. The general term doesn't really care what happened in the beginning. All right, so there's my general term. And negative x plus x really cancels out. So negative x plus sine x is really just the sine series, but I started x cubed instead of x to the first. But Mrs. Weber, you canceled out a term. Don't you have to change the general term? Still no. No, I do not, because all of my later terms still follow this format. So my general term stays exactly the same. Addition and subtraction does not affect the general term. It affects the other terms in the beginning, okay? And you don't have to worry about the general term. All right, I want to do one more with you, and I think the one I am going to do is 6. X e to the negative x squared. So let me jump down here. X e to the negative x squared. All right, so if I want to do that, first thing I'm going to do is say, you know what? I should write out e to the x. So e to the x, e for everything. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the n over n factorial. Everything. All right, now I got to think about the order that things happened here. I multiplied e to the negative x squared by x. So I'm going to write this as e to the negative x squared and change all of my x's into negative x squared. So 1 plus negative x squared plus negative x squared squared over 2 factorial plus negative x squared to the 4th over, oops, I forgot my 3, to the 3rd over 3 factorial plus negative x squared to the 4th over 4 factorial plus negative x squared to the n over n factorial. Okay, looks good. Can it be simplified? Yeah. Do I have to simplify it? No. Then I'm supposed to take that and e to the negative x squared and multiply it by x. Well, if I multiply the left-hand side by x, I need to multiply the right-hand side by x, and multiplication is distributive, so I need to multiply every single term by x. So x e to the negative x squared is going to be x. All right, now I feel like I kind of want to multiply this here. So that would be negative x squared times x, which is negative x cubed. All right, this is going to be negative x squared squared, which is going to be positive x to the 4th. And then I give it another x, so that's positive x to the 5th over 2 factorial. All right, and then I have negative x squared cubed, which would stay negative. X squared cubed would be x to the 6th. Then I multiply by x again. I have negative x to the 7th over 3 factorial. And then this is going to be positive x to the 9th over 4 factorial. Now I'm going to write my general term. And I'm going to look at this and say, okay, I want to build my general term from scratch. Okay, I have 2 options here. Option number 1, I use this old general term and just put an x in front of it. And honestly, that's totally fine. But I want you to also experience what would happen if I tried to build it from scratch. What would happen if I didn't have this other general term? We do, and if you do, you should use it. But just, I'm going to suspend that for a second and say, what if I had to build it from scratch? What would I do? Well, I would look at that denominator and realize it's over n factorial. I can't change that. Those denominators are going up one at a time. My terms are alternating. So I know I have a negative 1 to the n on top, but I'm noticing that when n is even, I have a positive. So negative 1 to the n is where it stops. I don't need the n plus 1. And then my power on top, let's see, how does this 9 relate to this 4? Well, it's 2 times 4 plus 1. 3 and 7, 2 times 3 plus 1. So my exponent is 2 times that number on the bottom plus 1. And that's another way to write that general term. Okay, so there are two forms, technically there's more, of the general term. It can be this, or it can be the thing I just created. So that, my friends, is how you create and manipulate Maclaurin series that you already know and create other series from them. Da da da. I hope this was informative and that you are having a glorious day today. Enjoy the rest of it.